Okay, so now we're looking at using density to calculate mass or volume. So you have mass or you have volume. You know what the material is made of, so you can look up its density in a reference. And now you need to find that other thing. So in our first question, I have 275 centimeters cubed of gold. What is the mass of my gold? There are many different ways to solve this problem. We're going to look at two of them, and you need to be able to solve in both ways. The first one is using the density equation. So density equals mass over volume. Again, just like before, we need to make sure that we're working in our units for density, which are grams per centimeter cubed or grams per milliliter. So we always need to be working in those units. So I have 2.75 centimeters cubed of gold. That's my volume. Again, we must recognize centimeters cubed or milliliters or liters. That is a unit of volume, so I can plug that in for V. So the other thing that I'm going to need is the density of gold. And I'm going to go to my reference, look it up, and gold has a density of 19.3 grams per centimeter cubed. So I can just plug that in. So I plug that in for density, 19.3 equals mass, which is what I'm trying to find, that's my unknown variable, divided by 2.75. So to solve, I have to isolate my variable, get it by itself. So I'm going to multiply both sides by 2.75. Those cancel out. So M equals 2.75 times 19.3. And when I do my operation, M equals 53.075 grams. All right, so that's using the density equation. The other thing I need to be able to do is use dimensional analysis to solve this same problem. So I'm going to use my dimensional analysis steps the same way that we've done before. So dimensional analysis setup. What is this question asking me for? It wants to know what is the mass, so my unit of mass is grams. I'm going to start with my given. I only have one given, so that makes that easy, 2.75 centimeters cubed. Now, I need to convert from centimeters cubed or volume to mass or grams. So I need a conversion factor to do that. And that conversion factor comes from density. If I look over here at the way I've written my density, I'm just going to change its form to be written from being written like this to be written as a conversion factor. So when I write density as a conversion factor, it's just 19.3 grams over 1 centimeter cubed. And that's what this unit is telling me over here anyways. It's 19.3 grams per 1 centimeter cubed. So I'm just going to write it in that format. Now I have a conversion factor that I can plug into my dimensional analysis setup. Centimeters cubed needs to go on the bottom, so I'm going to plug it in just the way that it is. 19.3 grams divided by 1 centimeter cubed. My units cancel out for centimeters cubed. I'm left in grams. Do the same operation, I get the same answer, 53.075. Now we're going to go ahead and take a look at our second problem. What is the volume of 200 grams of brass? So we're going to start the same way. We're going to solve first with our density equation. Density equals mass divided by volume. This presents a particular challenge, or at least a common mistake that is made by many students, and that's when solving for a variable that is in the denominator. Oftentimes we solve for that variable incorrectly. So we'll have to pay close attention to that. So again, I'm going to look at my given. I have 200 grams, so I can plug that in for my mass, and I'm working with brass. So I'm going to go to my density reference, look it up. It has a mass of 8.4 grams per centimeter cubed. So I'll write that off to the side here, 8.4 grams per centimeter cubed. And now I'm going to plug in my value. So 8.4 which is the density, is equal to 200, which is my mass, divided by volume, which is my unknown variable, which is what I'm trying to solve for. So a lot of times in this situation, students want to just multiply both sides by 200, kind of like we did in this example problem up here when I multiplied both sides by 2.75. Well, if you do that, you're solving for volume, but volume is still in the denominator. We can't do that. The first thing we have to do is get volume, or V, out of the denominator. So I'm going to multiply both sides by V. Now V goes away on that side of the equation. So V times 8.4 is equal to 200. So now V is equal to, I'm going to divide both sides by 8.4. So V is equal to 200 divided by 8.4. So V equals 23.81 centimeters cubed. Again, this is volume, so it's centimeters cubed. All right, so solving with dimensional analysis helps us to avoid that incorrect or that common mistake that we see when solving for a variable in the denominator. So again, we'll set up the same way. Dimensional analysis setup. This question is asking me for volume. My unit of volume is centimeters cubed. My starting point is 200 grams. And again, get from grams now to centimeters cubed, so I need to use density as a conversion factor. Just like before, I'm going to write it as a conversion factor, 8.4 grams over 1 centimeter cubed. In this case, grams is here, so it has to go down here. I'm going to flip my conversion factor over, 8.4 grams, 1 centimeter cubed, and then divide and get the same answer, 23.81 centimeters cubed. Another thing that makes dimensional analysis a little bit easier to work with is our units. Remember, we have to work in grams per centimeter cubed or grams per milliliter. And both of these problems gave us units that were nice and easy to work with that we could plug into our equation. If I was given, instead of 200 grams, if I was given 200 kilograms, I cannot plug that value into my equation over here because this unit of mass has to be in grams. So if we start in dimensional analysis, because we're going to have to convert kilograms to grams anyways, I can easily just continue my dimensional analysis setup. So in many ways, dimensional analysis helps us to avoid some of the mistakes that we might run into when using the equation. But either way works, and you should be able to solve these problems both ways. Where's my recording?